Three-phase inverter with 120-degree conduction mode. This lecture is presented by R. Gangadevi, Assistant Professor, Department of Mechatronics Engineering, SRM Ministry of Science and Technology, Chennai. In this type of conduction mode, each SCR conducts for 120-degree duration. At any instant of time, only two SCR remains on. In this case, one period of inverter operation has been divided into 6 intervals, or simply you can call it as 6 modes. The modes are mode 1, mode 2, mode 3, mode 4, mode 5 and mode 6. The corresponding conducting thyristors for mode 1 as thyristor 1 and 6, for mode 2 thyristor 1 and 2, for mode 3 thyristor 2 and 3, for mode 4 thyristor 3 and 4, for mode 5 thyristor 4 and 5, for mode 6 thyristor 5 and 6. This is a circuit of a three-phase bridge inverter using SCR. The SCRs are labeled as T1, T2, T3, T4, T5 and T6. This SCR circuit has been connected to a constant DC input as well as connected to a star connected load. If you see mode 1, the thyristor T1 and T6 are conducting. So thyristor T1 is connected to the upper group of a thyristor and T6 is connected to a lower group of the thyristor. Now coming to mode 1 operation, thyristor 1 and 6 are conducting. If you see this circuit, the thyristor T1 and T6 are made as a closed switch. The T4, T3, T5 and T2 are going to act as an open switch. If you see phase A, the phase A is connected to thyristor T1 and phase B is connected to thyristor T6. If you take this diagram for phase A, the phase A is connected to a positive of the supply to thyristor T1 and phase B has been connected to the negative of the supply input to thyristor T6. So again you can simplify this circuit into an equivalent circuit which consists of only phase B and phase C. So here now we can find out the current flows through this closed circuit I is equal to Vs by 2R. Using this equation, we can find out the phase voltage of VAN as well as VBN. So using this current equation I is equal to Vs by 2R, we can find out what is VAN. VAN is a phase voltage of a phase is equal to I into R. So this I value you can substitute over here as Vs by 2R into R. This R will get cancel each other and finally you will get VAN is equal to Vs by 2. Similarly, we can find out the phase voltage of V phase. VBN is equal to minus I into R because this V is connected to the negative of the supply. So you can substitute this I value as Vs by 2R and this R will cancel each other. Finally, you will get VBN is equal to minus Vs by 2. So here if you see a C phase, the C phase is connected to open switch of T2 and T5 which means it is not connected to a supply input. So the voltage across this phase, the VCN is equal to 0. Using these phase voltage, we can find out the line voltage for mode 1 operation as VAB, VBC and VCB. VAB can be calculated as VAN minus VBN. VAN, the value you can substitute over here as Vs by 2 minus VBN is minus Vs by 2. So we can calculate VAB is equal to Vs. Similarly, we can calculate VBC. The VBC is equal to VBN minus VCN. So you can substitute the value of VBN as minus Vs by 2 minus VCN is equal to 0. Now I can take this VBC. VBC is equal to minus Vs by 2. Similarly, you can find out VCA. VCA is equal to VCN minus VAN. So you can substitute the value of VCN is equal to 0 minus VAN is equal to Vs by 2. So you can calculate the value of VCA. The VCA is equal to minus Vs by 2. Now coming to mode 2, the thyristor 1 and 2 are conducting, which means the phase A is connected to thyristor T1 and phase C is connected to thyristor T2. Which means the thyristor T1 and T2 are act as a closed switch. T4, T6, T3 and T5 are going to act as an open switch. So here the phase A is connected to the positive of the supply input through thyristor T1 and the phase C has been connected to a negative of the supply input through the thyristor T2. So you can simplify this circuit as an equivalent circuit like this. So here the A is connected to the positive of the input supply and C is connected to the negative of the input supply. So now we can find out the phase voltage of VAN as well as VCN. Here the VBN is equal to 0 because the V is connected to the open switch of T3 and T6. The V is not connected to the supply input. Now we can find out the phase voltage using this equation I is equal to Vs by 2R. We can calculate what is VAN as well as VCN. So VAN is equal to the current flows through the resistor I into R, which gives Vs by 2, it's equal to VAN. So here the VBN is equal to 0 and VCN is equal to minus I into R because the C is a phase which is connected to the negative of the supply. So you can substitute this I value as Vs by 2R into R. This R will get cancel each other and VCN is equal to minus Vs by 2. So using this phase voltage, you can calculate the line voltage of mode 2 operation. So here the VAB is equal to VAN minus VBN. So here the VAN you can substitute as Vs by 2 minus VBN is equal to 0. Therefore, the VAB is equal to Vs by 2. Similarly, we can find out the VBC. VBC is equal to VBN minus VCN. So here you can substitute the value of VBN is equal to 0 minus VCN is equal to minus Vs by 2. Therefore, we will get VBC is equal to Vs by 2. Similarly, we can find out VCA. The VCA is equal to VCN minus VAN. So here the VCN is equal to minus Vs by 2 minus VAN is equal to plus Vs by 2. Therefore, we will get VCA is equal to minus Vs. Now coming to mode 3 operation, thyristor 2 and 3 are conducting, which means thyristor 2 and 3 are going to act as a closed switch. Thyristor T1, T4, T6 and T5 are going to act as a open switch. So here the phase B has been connected to a positive of the supply through thyristor T3 and phase C has been connected through a negative of the supply through thyristor T2. So this circuit can be simplified as an equivalent circuit like this, which consists of only P and C phase. So here the P phase has been connected to the positive of the supply input and C phase has been connected to the negative of the supply input. So using this equivalent circuit, we can find out the phase voltage of VBN as well as VCN. So as we all know that the I is equal to Vs by 2R. So you can find out what is VBN. The VBN is equal to I into R. So we can substitute this I value here as Vs by 2R into the R value. You can find out VBN is equal to Vs by 2. So here in mode 3, the A phase is connected to the open switch of T1 and T4, which means the A phase has not been connected to a supply input. So you can find out the voltage for A phase voltage of A phase VAN is equal to 0. Similarly, you can find out the VCN. The VCN is equal to minus I into R because the C phase is connected to the negative of the supply input. So VCN is equal to minus I into R. You can substitute this I value as Vs by 2R into R. This R and R will cancel each other and finally you will get VCN is equal to minus Vs by 2. So using these phase voltage, we can calculate the line voltage of mode 3 operation as VAB, VBC and VCA. So VAB can be calculated as VAN minus VBN. You can substitute the value of VAN here as 0 minus VBN is Vs by 2. Therefore, we will get VAB is equal to minus Vs by 2. Similarly, you can find out VBC. VBC is equal to VBN minus VCN. So you can substitute this VBN is equal to Vs by 2 minus VCN is equal to minus Vs by 2. Therefore, we will get VBC is equal to Vs. Similarly, we can find out VCA. VCA is equal to VCN minus VAN. So you can substitute the value of VCN is equal to minus Vs by 2 minus VAN is equal to 0. Therefore, we will get VCA is equal to minus Vs by 2. Now coming to mode 4 operation, the thyristor T3 and T4 are conducting, which means that thyristor T3 and T4 are going to act as a closed switch. T1, T6, T5 and T2 are going to act as an open switch. So we can see that phase A is connected to a negative of the supply input through thyristor T4 and phase B has been connected to a positive of the supply input through thyristor T3. So we can simplify this circuit and you can make it as an equivalent circuit which consists of only B phase and A phase. The C phase it is connected to an open switch, which means it is not connected to a supply input. So here the equivalent circuit consists of only B and A phase. So you can find out the phase voltage of VBN as well as VAN. Here the phase voltage of VCN is equal to 0. So we can factor the phase voltage of VAN. VAN is equal to minus I into R because the A phase has been connected to the negative of the supply input. So you can substitute this I value here as Vs by 2R. So you can cancel this R will cancel each other and you can get VAN is equal to minus Vs by 2. Similarly, you can find out the value of find out the phase voltage of VBN. The VBN is equal to I into R. So you can substitute the value of I over here. This Vs by 2R into R. This R will get cancelled each other. Finally, you will get VBN is equal to Vs by 2. So here the C is connected to an open switch. So the phase voltage of this C phase is going to be 0. Using this phase voltage, we can find out the line voltage of mode 4 operation. So here the line voltages are VAB, VBC and VCA. So VAB can be calculated as VAN minus VBN. So you can substitute the value of VAN here as minus Vs by 2 minus VBN value is Vs by 2. So if you solve this one, you will get VAB is equal to minus Vs. Similarly, we can find out VBC. VBC is equal to VBN minus VCN is equal to VBN. You can substitute the value as Vs by 2 minus VCN is equal to 0. So if you solve this one, you will get VBC is equal to Vs by 2. Similarly, you can find out VCA. VCA is equal to VCN minus VAN. You can substitute the VCN value as 0 minus VAN is equal to minus Vs by 2. So therefore, you will get VCA is equal to Vs by 2. Now coming to mode 5 operation, thyristor 4 and 5 are conducting, which means the thyristor 4 and 5 are going to act as a closed switch. Thyristor T1, T3, T6 and T2 are going to act as an open switch. Now if we see the phase, A phase, the A phase is connected to a negative of the supply input through thyristor T4 and C phase has been connected to a positive of the supply input through T5. You see phase B, the phase B is connected to an open switch. This phase B is not connected to the supply input. So if you measure the phase voltage across this B and N, the voltage is going to be 0. Now this circuit is made simplified as an equivalent circuit like this, which consists of two phases, they are A and C phase. So here now we can find out the phase voltage of VCN as well as VAN. So VCN can be written as I into R because the C is connected to the positive of the supply input. So current will start from positive to negative, positive to the neutral point. So that is written as I into R. So you can substitute this I value as Vs by 2R. Now we can solve this one. You will get VCN is equal to Vs by 2. Similarly, we can find out the phase voltage of VAN. VAN is equal to minus I into R. Because the A is connected to the negative of the supply, the current will leave from the current go from positive to the negative of the supply. So here you can substitute this I value. I is equal to Vs by 2R. So this RR will can cancel each other, and we can find out VAN is equal to minus Vs by 2. So in this case, the B phase is not connected to the closed switch, so the input current will not come to a phase B, will not come to phase B. So VBN, if you measure the voltage, phase voltage for phase B, the VBN is going to be 0. So using this phase voltage, we can find out the line voltage. So the line voltage for mode 5 operation VAB, VBC and VCA can be calculated like this. VAB is equal to VAN minus VBN. VAN, we can substitute the value of minus Vs by 2 here, minus VBN is equal to 0. So to solve this one, we will get VAB is equal to minus Vs by 2. Similarly, we can calculate VBC. VBC is equal to VBN minus VCN. We can substitute the value of VBN here, minus VCN is equal to Vs by 2. Therefore, we will get VBC is equal to minus Vs by 2. Similarly, we can find out VCA. The VCA is equal to VCN minus VAN. We can substitute the value of VCN here as Vs by 2 minus VAN is equal to minus Vs by 2. If we solve this one, we will get VCA is equal to Vs. Now coming to mode 6. Thyristor 5 and 6 are conducting, which means the thyristor 5 and 6 are going to act as a closed switch, and T1, T4, T3 and T2 are going to be act as an open switch. If you see the phase D has been connected to thyristor T6, and through the current will flow to the negative of the supply input, which means the phase B is connected through to the negative of the supply input through thyristor T6, and phase C has been connected to thyristor T5 and is connected to the supply input, first of the supply input. We can simplify this circuit, and we can make a equivalent circuit, so which consists of only phase B as well as phase C. So using this current equation, we can calculate the phase voltage of VCN as well as VBN. So the VCN can be calculated as I into R. The current flows through this resistor is I into R. So you can substitute the I value here, and we can find out the VCN is equal to Vs by 2. Similarly, you can find out VBN. The D phase is connected to the negative of the supply, so we'll get minus I into R. You can substitute the value of I here. You can find out the VBN value. VBN is the phase voltage. For B phase is equal to minus Vs by 2. Here the A phase has been connected to open switch of T1 and T4, and this A phase is not connected to a supply input, which means the phase voltage of VAN is equal to 0. So using this phase voltage, we can calculate the line voltage for mode 6 operation. For mode 6, the VAB is equal to VAN minus VBN. We can substitute the value of VAN here at 0 minus VBN is equal to minus Vs by 2. Therefore, you will get VAB is equal to Vs by 2. Similarly, VBC is equal to VBN minus VCN. You can substitute the value of VBN minus Vs by 2 minus VCN is equal to Vs by 2. Therefore, we will get VBC is equal to minus Vs. Similarly, VCA is equal to VCN minus VAN. We can substitute the value of VCN is equal to Vs by 2 minus VAN is equal to 0. So if you solve this one, you will get VCA is equal to Vs by 2. So here, the line voltage and phase voltage of 6 modes of operations have been tabulated over here. So the first three, VAN, VBN, VCN represents the phase voltage. VAB, VBC and VCA represents your line voltage. For all the 6 modes of operation, the VAN, VBN, VCN and VAB, VBC, VCA have been listed in this table. So using this table, we will see how to draw the waveform for a three-phase inverter for 120-degree mode of operation. So here, with respect to time, I have been made the phase voltage of VAN, VBN and VCN, as well as the line voltage of VAB, VBC and VCE. So here, it has totally 6 modes of operation. So I have been divided the modes of mode 1, mode 2, mode 3, mode 4, mode 5 and mode 6. Now if you see the phase voltage of VAN for mode 1, the value is Vs by 2. For mode 2, Vs by 2. In mode 3, it goes to 0. Mode 4, minus Vs by 2. Mode 5, minus Vs by 2. Then mode 6, again reaches to 0. So the same way you can draw a waveform of VBN. The VBN is equal to, for mode 1, minus Vs by 2. For mode 2, 0. For mode 3, plus Vs by 2. For mode 4, plus Vs by 2. For mode 5, 0. For mode 6, minus Vs by 2. Similarly, you can draw a waveform for VCN. The VCN, the mode 1 starts with 0. Then it goes to minus Vs by 2. For mode 3 also minus Vs by 2. For mode 4, 0. For mode 5, plus Vs by 2. And mode 6 also plus Vs by 2. A similar way, you can draw a line voltage waveform of VAB, VBC and VCE. So here for VAB, for mode 1, it goes to Vs, then it goes to Vs by 2, then minus Vs by 2, then minus Vs by 2, then plus Vs by 2. For VBC, start with the negative side, minus Vs by 2, then plus Vs by 2, then plus Vs, then plus Vs by 2, then it goes to minus Vs by 2, then it comes to minus Vs. Similarly, you can draw a line voltage of VCA. VCA starts with minus Vs by 2, so it starts with minus Vs by 2, then it goes to minus Vs, then it goes to minus Vs by 2, then it goes to plus Vs by 2, then it goes to plus Vs, then it goes to plus Vs by 2. Thank you for watching this lecture.